So this is, now we're getting bottom up. This is a bit about technology, but we're running late, so I will keep this short. So talk a bit about the language Erlang, and which is open source, of course, and some issues around that. So I just want to point this out, right? Yes, it was developed by Ericsson, which is a telecom company, but no, it's not a telecom language. This is actually quite important, and the whole system itself is not a telecom system directly, okay? So I'll be very quick here, but what we were trying to do originally was look at designing software for building telecom type applications. That's what we're out to do. We're a lab doing this. Getting back to what Simon said, yes, we were using BSD 4.0 to start off with it, so we were on that. We were actually Ericsson's first Unix system at all. But what we found out was that what we needed to solve, the problem we needed to solve, was actually not telecoms oriented. All the telecom stuff had been done. We didn't need to control the switch because someone had written that software. So we had to do a problem something like this. We had a lot of concurrency going on in the system. We had timing constraints. The system could never block. We needed distribution, continuous operation and maintenance, and fault tolerance in the system. And if you look at there, there's nothing about telecoms in this. This is actually quite important for later on as well, too. So, yeah, this is just developing. We were out to solve the problem. This is what our goal was. We weren't out to develop a specific type of language or a specific type of system. We were trying to solve the problem. Everything in the language and the system was around this. Well, first principle, we need lightweight massive concurrency, asynchronous communication, process isolation, so when things crash, they wouldn't take down the rest of the system, for example, all these type of things. We need support for error handling and continuous evolution of the system. We felt concurrency and error handling, things like this, were so important, you don't put them on as a library. On top, you bake it into the system. We wanted high-level language. We wanted simplicity. The basic system and the basic ideas in the bottom of the system should be simple. If you get the simplicity right, that means you can build any level of complexity on top of it, but it's all understandable, right? And also we found we provide tools, not solutions. And we typically found that the hard way, because when we tried to provide solutions, they usually didn't work. So it's much better providing tools and letting the users use it. So, yeah. And I just want to say, all this went into the Erlang language. It's a simple functional language. It's like the concurrency primitives in there, the asynchronous communication, the error handling, etc. All this is in the language. It also went downwards into the implementation of the virtual machine, which contains support for all these things in the virtual machine. So the functional language properties, lightweight massive concurrency, and we are truly talking massive concurrency here. We're talking things like that, like millions of processors on one machine running, and there are serious systems that do this. The communication, the error handling. You have systems which just, the system as a whole never crashes. Things might go wrong and it can crash, but the system does not. The continuous evolution, there's support for it. There's support for the soft real-timeness. It is practically impossible to get to block the Erlang system. You can if you really put effort into it, but by default it just does not block. There is a lot of support for powerful introspection tools as well. This is nothing really surprising, but it's all there. And this is what we call the Erlang ecosystem. It builds on top of this. So at the base, you have the Beam, which is the Erlang virtual machine. You have Erlang, the language, and you have something called OTP, which stands for Open Telecom Platform, but there's no telecoms in it there either. On top of that, you can have a number of languages and systems running, which we call part of the Erlang, which we call the Erlang ecosystem. And if they're done correctly, they can all interact with each other and talk with each other, and the benefits you get is more than any basis of these systems running on it. So this is what we call the Erlang ecosystem and the development for it. And the important thing here is that Erlang and the language here, nothing contains anything which is specific to telecoms. This was done inside Ericsson. And this was a proprietary product inside Ericsson, which Ericsson were using in some places in their systems. However, we went open source. And the 20 years again is important here, because we went open source in 1998. So that's something Simon missed in his list of important points from 1998, that Erlang was open source in 1998 for it. Right? This took a lot of effort to do this. This was a problem because Ericsson, this did not come naturally to Ericsson for a number of reasons. They're not a software company. So what do I mean by this is, yes, they produce an awful lot of software, and basically every product they have contains software. So in that sense, they're producing a lot of software, but they're not selling software. They're selling products which use software inside, so their idea of handling software just didn't happen to them. Right? This meant it difficult to get them to think about software as something separate from the products they were doing as a base for doing open source in the future with it. That's also why it was important, for example, that that the system itself did not contain any telecoms for it, because then they would have gone outside. This took a lot of work, and the person who was mainly behind this was a woman called Jane Wallerud. She was working on sales and marketing of Erlang internally inside Ericsson, and she felt that this would very suit this system, this software, our designs, the OTP system would be very suitable for making open source. And she put a lot of effort into convincing management that this was viable open source software. It would not harm Ericsson if it became open source. It would be big support to them because we get feedback from the system and help and things like this for it as well too. It was also a legal problem because they had to convince the legal department here that if they made this open source, they needed the right type of licensing for it, so it wouldn't cost Ericsson if someone used it and it crashed or something like this for it. And all these things, she put a lot of effort into convincing that this worked. And in 1998, Erlang became open source. And I think it was Ericsson's first open source software. They still use it internally in products, and now it is spread quite a lot. It's an infrastructure system. You'll find a lot of infrastructure systems are written in Erlang. You don't see it. Like all good infrastructure, you don't see the infrastructure, it's just there, and this works for it. What the cathedral versus bazaar here what I meant here was that how the open source and the maintainers of the system interact with the users who use it and who want to extend it. This becomes quite difficult in some ways because it is very much infrastructure. And you have to be very careful when you're working with infrastructure because any changes you make will affect an awful lot of people. And a lot of the groups or systems or products that you will affect, you don't know about. Which means they, at the base level of the Erlang system, they very much like to keep control of what goes into the system. They are very restrictive. They have a lot of requirements for backward compatibility and things like this for it, just to make sure that if you're using this system, you can depend on it in the future as well. However, on top of the Erlang system, the Erlang base, of course, there are a lot of applications written which are open source. You have other languages. For example, I'm not going to talk about here, but there's a very common language becoming more common now called Elixir, which is also open source, of course, and they have a different set of requirements. They're both at the language application level where they have to be careful, but there are a lot of packages written on top which don't have to worry about this. So whether we're Cathedral, whether we're Bazaar, depends very much where you look and what you're doing for it. And yeah, it's worked. The open source has worked. It's now Apache 2.0 license for it. It was a slightly hacked Mozilla license from the beginning, but now it's open for it. And I think the result of it has been good. Not just the fact that it's now available in the public, but the feedback from the system has worked in that they've received help from users, from companies using it who have come back with suggestions and ideas for code for improving the system as well. So this has worked. Though it's not free in the sense that it is quite a lot of extra work. And that's basically all I want to say here, there's an Erlang meetup after lunch, so if you want to hear more about Erlang, please come along to that. I don't know exactly who's talking there, but we'll find out. Yeah, I think that's about it. And I didn't take too long time,
Okay.
which is quite remarkable for me. Okay, thank you.